Now let's start with exercise 10.1. The first question is here, you are given 4 points and you want to present these points in this Cartesian plane. So I'll consider 2 coordinate axes. Now I'll take here points like 1, 2, 3, 4, 5 here. You know, here you negative points, -1, -2, -3, -4, suppose -5. Here you have 1, 2, 3, 4, 5. And same way here, -1, -2, -3, -4 and -5. Fine. Now we just plot these points. You know how to do this. For example, first point, -4 and 5. So -4 from here and 5 from here, y-axis. -4, 5. So this is point A. Okay. Then 0, 7. So x coordinate is 0, that means it's on y-axis. 6 and 7, so it is somewhere here. Okay, this is y-axis. 7 is somewhere here. So this is point B. C, 5, -5. So 5 from x-axis and -5 from y-axis. So C is somewhere here. And this will be obviously in the third quadrant, -4, -2. So -4 from here and -2 from here. This is point D. So we have these 4 points. I'll join this. So I'll get the quadrilateral. A, B, then C here, then D here, and then again A. You know, quadrilateral is a closed figure having how many sides? You know, 4 sides. 1, 2, 3 and 4. This is a quadrilateral. This you know very well. Now what is asked? Also find its area. Now we don't have any formula to get the area of quadrilateral. So what we'll do in such cases, we divide into several triangles and you have the formula to get the area of a triangle. Fine. So you can join these two, you'll get these 2 triangles. You can join these 2. So again you'll get 2 triangles. So I'm joining these 2. Okay, for example, this is just for our information. Okay, so now you have 2 triangles. One is ABC and the other one is ADC. So I'll write here area of the quadrilateral ABCD, that is equals to area of triangle, this triangle ABC plus area of this triangle, area of triangle, which triangle? ADC. Fine. We call this as equation number 1. What we do now? You did such things in 10th standard. You get the area of triangle ABC. In the theory, we already stated the formula. Fine. And from there, you can find the area of a triangle. So let's do that. Now we find the area of triangle ABC. So you are going to use A, B and C here, which is equals to half. You have one expression here, right? Which expression? Here, you know, x1, y2 minus x2, y1 plus here what will get? You know, x2, y3 minus x3, y2. And then finally here 2, then 3. So plus x3, now y1 minus x1, y3. This is our ready formula, we know. Now we just put the values. If you know by some another way, you can write that formula and you can get the area of a triangle. Okay, so let's put the values. Now what is x1, y1 for us? This is x1, y1, this is x2, y2 and this is x3, y3, remember, because we have considered triangle ABC. If you want, you can write here your -4, 5, which is x1, y1. B, x2, y2, 0, 7, that is x2, y2 for us. And what is C? That is nothing but 5, -5, which is here nothing but x3, y3. Okay, now we just place the value and we'll simplify. Half is already there outside. You can just put the values. If you want, you can do like this. You can take x1 common from this 2 and you can write y2 minus y3 inside the bracket. That way also you can do. I'll do that way. x1, what is x1? x1, you know, it is minus 4. Minus 4 inside the bracket y2 minus y3. That is nothing but the 7 plus 5. Okay. x2, I'll take common from this 2. Where is x2? Over here. So I'll take x2 common. So what will get inside the bracket? y3 minus y1. y3 minus y1. Where is y3? Here minus 5. And y1 is 5. So this will be minus 5 minus 5. Okay. Then, sorry, x2 I forgot to place. What is x2? x2 is 0 here. So this will be 0. I'm sorry, this I forgot to put. So anyway, this will be 0. Then from these two terms, you take x3 common. What is x3? That is 5. And what about from these two? y1 minus y2. y1 is 5. And this is how much? y2, it will be 7. So 5 minus 7. Now question is just simplification here. So that I'll do on the next page. So here we have half, which is as it is. This is minus 4 into 12 plus middle term is 0 and 5 into minus 2. Okay, so we'll get half into, this is actually you have modulus here. This is this would be, you know, minus 58, but it will be 58 taking modulus. So 29 unit square. That's area of triangle ABC. Now again we'll go for area of which triangle? Again area of triangle ADC. Area of triangle ADC. Again you have half that formula. Now here A, what was A? It was minus 4 comma 5. That is x1 y1 here. D, that is your x2 y2. What is D here? D, you know, it is nothing but minus 4 minus 2. So this is your x2 y2 here. And C, ADC. So what is C? That is 5 comma minus 5. So it would be x3 y3. Right? Just place here the value as I did in the previous case. Get the area. You will see that it would be 63 by 2. Right? This much I leave it for you. I wrote it directly. It would be this. And therefore by 1 area of the quadrilateral ABCD, that is equals to first area, which was 29, and then second area it would be 63 by 2. Fine. So here if you multiply with this 2, so 58 plus 63 by 2, so we'll get the finally here 121 by 2 units square. That's required area. Fine. We have used the triangulation. That is important here. We have divided into two triangles and we have got the area. Okay. Now next question. Question number 2. Second question. What it says? Base of an equilateral triangle. So we have an equilateral triangle here. Equilateral triangle. That means all the sides are equal. Equilateral triangle with side 2A, that means measures of all the sides equals 2A. Side 2A lies along the y-axis, okay, such that the midpoint of the base is at the origin, and the question is get the vertices of a triangle. Fine. So with here side 2A, side equals to 2A, that's given to you. So let me draw that diagram here. So these are the two coordinate axes here. Now here base is along y-axis, that's given. Okay, so here there is a base and the midpoint is origin here. So this is the midpoint of this base. Total length is 2a. So this much has to be a, this much has to be a. So total length is 2a. If I call this as a, here b, then obviously coordinates of a will be 0, a because it is on the y-axis. So first coordinate has to be 0 and here it is in the lower half plane, so 0, minus a. Now this being midpoint, fine. Now here the third vertex must be on the x-axis, somewhere here. Let me call this as, for example, C. It will be on the x-axis because this is the midpoint. Now this being midpoint, if you draw one line segment here, this would be actually perpendicular. So this become a right angle triangle. It's obvious. If this is here line segment joining the midpoint and the vertex opposite to it, then this become perpendicular here. Or obviously you can see in the diagram also that this is a right angle triangle. This is origin, this is C. We want the coordinates of C here. Second coordinate is obviously 0 because it's on the x-axis. Question is first coordinate. That depends upon this length. Let me call that as x. Now this being equilateral triangle, this is 2a, This side is also 2a, this is also 2a. But we don't want this right now. So I'll use the right angle triangle here concept. In triangle AOC by Pythagoras, AC square equals to, AO square plus OC square. What is AC square? It would be 4a square. What is AO? That is A, so A square, and this is x square. So x square will be 3a square. So x will be plus or minus root 3a. Right? It might be on the other side also. So you may have C dash somewhere here, one more triangle like this. So here coordinates of the C will be root 3a, 0 or minus root 3a, 0. Fine. Coordinates of A and B are fixed here, 0, a and 0, b. So therefore finally vertices are this. Vertices are, one is a, 0, a, then 0, minus a. Here you have root 3, 0 or plus root 3a, 0. These two are fixed here, 0, a and 0, minus a. Fine, either this or this. And third question, find the distance between P and Q. So here PQ by distance formula. It is given by x1 minus x2 the whole square plus y1 minus y2 the whole square. This is general distance formula. We know it. Now what we want in the first sub question? In the first sub question, you are asked when PQ is parallel to y-axis. PQ is parallel to y-axis. Now when any line is parallel to y-axis, then everywhere x coordinate remains same. So x1 equals to x2. Suppose if the line is like this here, x-axis, y-axis, somewhere here, then x coordinate comes from this. So everywhere x coordinate remains same. Here, here, if I take this point here also, y coordinate would be different. So therefore x1 equals to x2. Put there. So PQ equals to, this will be 0. So root of y1 minus y2 the whole square. So this is modulus y1 minus y2. When you take the square root of a square of a number, then it's always modulus x. Right? This might be negative also. That's why we put the modulus. Okay. Now what about the second sub question? There PQ is parallel to x-axis. It means it talks about horizontal line. So it's like this here. If it is horizontal line like this, then y coordinates comes from this. So if I pick up any point here, this point or this point or this point, everywhere y coordinate remains same. X coordinate depends upon the point, but this will be equal because it comes from this one when it is parallel to x-axis. So you can say that here y1 equals to y2 because y1, y2 all will be equal when it is on the horizontal line. So therefore here PQ equals to root of, this will be 0 now. So x1 minus x2 the whole square. Taking square root, you have in general modulus x1 minus x2. Right? What's important conclusion you have drawn in this solution? When any line parallel to y-axis, then everywhere you know which coordinate remains same, x coordinate remains same. On the y-axis everywhere x coordinate is 0 because it passes through origin. If it is passes through 2 here, then everywhere 2, 2, 2. So on such line, on vertical line, everywhere x coordinate remains same. Here on the horizontal line, everywhere you see y coordinates comes from this. If y coordinate is 4 here, then 4, 4, 4. Everywhere y coordinate remains same. So y1 equals to y2 and therefore we have this. Okay. Next question, question number 4, what it says. In the fourth question, find a point on the x-axis which is at equidistant from given 2 points. We call them as A and B, 7, 6 and 3, 4. You have these 2 points. We want a point on the x-axis. So let that point be, when you want a point on the x-axis, then y coordinate is 0. When I pick up a point here, then y coordinate is 0 on the x-axis, you know. So you just need to get the x coordinate of that point. Now this point is at equal distance from A and equal distance from B. So this is given. PA equals to PB. Distance of that point P from A and B are equal. Now what we do? We don't have any other thing. We need to use the distance formula. So root of, you know distance formula, x minus 7 the whole square plus 0 minus 6 the whole square, 36. Here x minus 3 the whole square plus this is 16. Now squaring. Such things you might have done even in 10th standard also. Squaring. So x minus 7 the whole square plus 36 equals to x minus 3 the whole square, 16. So here if you expand it here, number of terms will get cancelled. X square minus 14x plus 49 plus 36 equals to x square minus 6x plus 9 plus 16. We are interested to find what? Just x, because here y coordinate is 0. So we just need to simplify this. Here x square will get cancelled. You take 6x over here, so this will be minus 8x. And on the other side I'll take these two expressions over there, so you will get this is 25 here and this is 11, so you will get the minus 60. Take on the other side. So therefore x equals to how much? You will get 15 by 2, right? 15 by 2 here. So therefore the required point is 15 by 2, 0. Why we have chosen 0 as a second coordinate? Because you are asked on the x-axis. Same way if you are asked on the y-axis, for example, and if I want to pick up the point, you need to select like this, 0, y, because on the y-axis x coordinate is 0. Keep in your mind, on y-axis x coordinate is 0, on x-axis y coordinate is always 0. Okay, next question. There is nothing, just to understand the question. It's a very elementary question. In the fifth one, just read the question. Find the slope of a line. So now this is the beginning of slope which passes through the origin. Now when you are asked slope of a line, then immediately you must have two things in your mind. Either 2 points on the line or slope or angle. inclination angle. If you are given the angle, then slope is tan theta, you know. As far as slope concerned, just recall the theory. If you are given the angle of inclination, this angle, then the slope is tan theta. We know, we have discussed in the theory. Or if you are given 2 points on the line, you are not given this angle. Suppose you are given 2 points, then you know difference of the y coordinates upon difference of x coordinates, right? So whenever there is a question of slope, immediately you need to ask 2 things to yourselves. Is there angle theta? Number 1. If no, then you must have 2 points on the line, right? So far in the discussion, we have these 2 formulas. Okay, so see here, you must have 2 different points on the line. Find the slope of a line that passes through origin. So what you have realized, 1 point must be origin. This is our line, for example, required line. I'm just drawing rough diagram that passes through origin. So 1 point you got, like x1, y1. And the midpoint of the line segment joining these 2. So midpoint of the given line segment equals to midpoint of given line segment PB. Midpoint equals to which line segment? Of PB. P and B you are given. So how do we get it? By just taking the average, you know. 0 plus 4, we already 0 plus 8 by 2, comma, what we have? Minus 4 plus 0 by 2. So from this we'll have 4 comma minus 2. Fine. So one more point on the line is this. 4 comma minus 2. 4 comma minus 2. 1 point was here. So required slope equals to, here I'll write required slope equals to, how do we get it? y2 minus y1, that is minus 2 minus 0 upon x2 minus x1, that is 4 minus 0. So finally we'll get the minus 1 by 2. That's required slope. I repeat, see what we did. First 1 point on the line you are given. Which point? Origin. This is already given. The other point on the line, that was the midpoint of this. So I got the midpoint, that is 4 comma minus 2, and then we have used which formula? y2 minus y1 upon x2 minus x1. So minus 1 by 2. That's the required slope. Fine. Let's go to next question. 6th. Such questions you did earlier in 10th standard, but there you were using distance formula. I mean indirectly Pythagoras theorem. Now here it is clearly mentioned that without Pythagoras theorem, right? You are not going to use the Pythagoras theorem. I'll call the given 3 points as A, B, C here. 4, 4. The other one is 3, 5. And the one more is minus 1, minus 1. You want to show that these are the vertices of a right angle triangles. At least one angle must be 90 degrees, not by Pythagoras theorem. So we have the concept of the slope. You know condition for 2 lines to be perpendicular. So what I'll do, I'll get the slope of line segment AB. You can write line segment or line. Okay. Then I'll get the slope of BC. You will see once I finish this, you will realize, okay, what's the slope of AB? y2 minus y1 upon x2 minus x1, 3 minus 4. This is 1 and here minus 1. So this is minus 1. What's the slope of BC? y2 minus y1 minus 1 minus 5 upon x2 minus x1, minus 1 minus 3. So this will be minus 6 by minus 4. So it will be 3 by 2. Okay. I'll get the slope of AC also. And now slope of line segment AC. What I'll show at the end, you will realize minus 1 minus 4 upon same minus 1 minus 4. So this is just 1. Now you see in these 3 slopes, the product of this and this is minus 1. Right? What you have noticed? The slope of AB into slope of AC equals to minus 1, right? That's your conclusion. What is the meaning of this? These two must be perpendicular. That means line AB must be perpendicular to AC, and therefore the measure of angle A must be 90 degree, and therefore proved. Therefore triangle must be right angle. Understood? So just rough diagram would be like this. Here the rough diagram would be this. For example, here this is line segment AB. Its slope is -1, and this must be AC here. This is AC here. Its here slope is -1, here slope is 1, and then you have BC here. Product of the slopes equals to -1, therefore these two must be perpendicular to each other. Recall last session theory. M1, M2 equals to -1 if and only if these two lines are perpendicular. Lines are perpendicular. We have already discussed. Clear? Understood? So no Pythagoras theorem. Suppose in first two, if I'm getting product equals to -1, then no need to find this. Getting me? Suppose here I'm getting -1 and here I'm getting 1. So product equals to -1, then no need to get the slope of the third one. Right? Product should be -1. Then corresponding line segment must be perpendicular to each other. We have not used the Pythagoras theorem here. Chalo, let's go to next question. You are asked for the slope in the next question. Find the slope of the line. You are given information about angle. It means you are going to use the tan theta formula here. What is given to you? Please read the question. Find the slope of the line which makes an angle of 30 degree with positive direction of y-axis. Here it is, angle with which axis? Y-axis. Normally when we use the angle for the slope, then that angle must be with the positive direction of the x-axis, remember. Okay? Measured in anti-clockwise. Okay, you know clockwise and anti-clockwise from the unit circle. In trigo we have used effectively. So I'll show it. But here the angle is with y-axis. When we get the slope, angle must be with x-axis. So we'll see how we are converting here. Let me just draw the diagram here in the question number 7. Right? What is given? That is line makes an angle with positive direction, positive y-axis. We need the angle with the positive x-axis, and then you can write the tan theta. Okay, so let me draw it here. So here in anti-clockwise direction, you know this is anti-clockwise, this is clockwise. From y-axis it makes how much angle? It makes 30 degree angle. So it starts from y-axis and anti-clockwise. This much angle of the line, 30 degree. So our line must be like this. If I show it, from where it passes, that's not important. This is the line. This is the line. Okay, this angle you are given with y-axis. In which direction? Anti-clockwise direction. Now, you know, if you want the slope, you need this angle. Here to here. Now this much is how much? You know, 90 degree. So what is this total angle from this to this? This total angle would be how much? It would be 90 plus 30. Fine. This is our theta in simple language. And once you know theta, you will get the slope now. So slope m equals to, here you are going to use the tangent of theta formula. In earlier examples, you were using what? You were using y2 minus y1 upon x2 minus x1 formula. Tan 90 plus 30, 120 degree. How will simplify this? You know now from trigo, this is nothing but 180 minus how much? 60. Pi minus something. Which quadrant? Second quadrant, where the tan is negative. So tan 60 degree. And what is tan 60 degree? That is, you know, root 3 with minus sign. So slope equals to minus root 3. This is the required slope here. In the next question, you want the value of x for which these 3 points are collinear. Let me call these as points A, B, C. Collinear means what? They fall on the same line. like this, A, B and C somewhere here. They are on the same line. Now here you can use distance concept, but we mainly use concept of the slope because that's a new concept you have studied. Now if 3 points are on the same line, if I get this slope and if I get this slope, both slope will be equal here. In fact, the slope of AC is also same. Out of these 3, if I take any 2 points, then slope will be same, because slope has nothing to do with the points. Slope has some connection with this inclination, you know, right? So if I take these 2 points or these 2 points or these 2 points, slope remains same. So whenever points are, let me write this, you can just note as the result, points are collinear. Points are collinear, that means whenever they are on the same line, if and only if slopes of any two points will be equal. If you take any 2 out of these 3, there are 3 ways, AB, BC and AC, slope will be equal. I hope this is clear to you, because slope has no relation with, you know, points. Even if I take these 2 again, slope will be same, because that slope has some connection with inclination of this line with the ground, that is with x-axis. Okay, so what we do, you can take for example these 2, x is involved here. So because of collinearity here, you can write slope of AB, and you can use this 2 equals to slope of BC. Normally when we have parallel lines, then we use the equality here, but lines will not be parallel because there is a common point B, remember. Fine. Now get the slope. What's the slope of AB? y2 minus y1, that is 1 plus 1. Is it? Upon x2 minus x1, that is 2 minus x, equals to, what's the slope of BC? 5 minus 1, which is 4, upon y2 minus y1, that is 4 minus 2, that is 2. You just simplify, so we'll get the value of x. Fine? That much you can do. This is just 2 and you can get the value of x. That's your answer. Okay, let's go to next question. You are given 4 points in the next question, 9th question. Let me call them as A, B, C, D. Normally whenever points are given, always label them. So minus 2 minus 1, 4, 0, then C, 3, 3, and one more, that is D, which is minus 3, 2. What you want to prove? You want to show that these are the vertices of a parallelogram. What is parallelogram? Opposite sides are equal or parallel, right? Now you might have done such questions in 10th standard using distance formula. So it's like this. If I just show the rough diagram. Okay, this is a parallelogram. Opposite sides are equal or parallel. In sequence you should write A, B, C and D. So what we do, we will not use distance formula. We show that the opposite sides are parallel. Get the slope of AB, get the slope of CD. You will notice that both the slopes will be equal. Fine. So I'll not do, I'll just write for you. Slope of AB, you get, how do we get it? y2 minus y1 upon x2 minus x1. Slope of opposite side, CD. You will notice that these two will be equal. Call them as 1. Then next, slope of this one, BC. Slope of BC. Then slope of AD. Slope of AD. Right. You will see that these two are again equal. How do we get the slope? Let me just do verbally for you here. AB. This is 1 upon here how much? 6. So this slope will be 1 by 6 here. Is it? Slope of this one is 1 by 6. What about CD? Let's do that. This is nothing but how much? 2 minus 3. That's minus 1. And this is minus 6. Again 1 by 6. This is 1 by 6. This is also 1 by 6. Similarly check for this two equal. So from 1 and 2 you can say that AB is parallel to CD and BC is parallel to AD. Opposite sides are parallel and therefore your conclusion is here quadrilateral ABCD is a parallelogram. You can use that concept of diagonal bisect each other. That is also concept, but I'm emphasizing here on the concept of slope. There are three ways. Use the distance formula, show that opposite sides are equal. Get the slopes, show that the opposite sides are parallel. Get the midpoints of the diagonals and you show that the diagonal bisect each other. And therefore again quadrilateral is a parallelogram. I've just used the concept of the slope here. Next question, question number 10. That's a good question. Find the angle between x-axis. Okay. So you need to know the slope of x-axis. Do you remember slope of the x-axis? 0, horizontal line. Right? X-axis, slope 0. Do you remember slope of the y-axis? Undefined. X-axis has no inclination with the ground, so slope is 0. This is very well known, you need to remember. I repeat, slope of x-axis or any horizontal line is 0 because it has no inclination or rising or falling with the ground, so slope is 0. And angle between x-axis and the line joining these 2 points, I'll call them as 3, -1 and 4, -2. So I need to get the slope of this. So what is the slope of line AB? So slope of line AB here, or line segment AB, whichever you write. By which formula? y2 minus y1. -2 minus gives us +1 upon x2 minus x1, 4 minus 3, which is -1. So here I'll call that as M2. Now you want the angle between what? Line AB and the x-axis. Do we have ready formula for that? Yes, we do have formula for that. Right? Let the angle between these two is alpha. Angle between these two. Angle between these two. Okay. Angle between x-axis and the line AB. Okay. So we use which formula? Tan alpha equals to, you have prepared formula, M1 minus M2 upon 1 plus M1 M2. Okay, we use this formula. Which formula? Tan alpha equals to, you know, which formula? Tan alpha equals to M1 minus M2 upon 1 plus M1 into M2. We already studied this. So put the value here. What is M1? 0. Right? So this is 0. This is 1 here. And this is again 1 plus, what is this? Here again 0. So we are getting 1. Tan alpha equals to 1. So you know alpha equals to 45 degree. Now some authors, you know, when I drop the modulus, you may have like these also. Tan alpha equals to -1 also. So in this case, what we'll get here, you know, alpha equals to, in that case, how do we write it? 1 second quadrant. So 180 degree minus 45. So how much? This will be, you know, 135 degree. So you can use these also. Both are, according to me, correct. If you consider that as the acute angle, this is the angle, or you can consider 135 also. Fine? It's like this. Suppose this is 45 degree, then this will be 135. Both are angles. Right, 135, like this, that way, either this or this. Normally acute angle is considered an angle between two lines. Question number 11, that's also an important example. The slope of a line is double of the slope of the another line. Okay, so there are two lines. Let M1 equals to slope of one line, slope of a line, and M2 will be the slope of the second line, slope of second line here. So if the slope of the one line is double the slope of the other line. So if I take the slope of one line as m, then this must be 2m. Right? So m1 is m here. What is m2? That is double, which is 2m. What is given in the question? Further, the tangent of angle between these two. Achha. So tan alpha you are given. Tangent means tan alpha. Alpha is the angle between these two, which is 1/3. What is asked? Find the slopes of the lines. So you want to find m1 and m2. This is the question. Slopes are m1 and m2 here. So we get these two to find this. This is the question. So here we simply use this tan alpha formula. What is tan alpha formula? You know, modulus m1 minus m2 upon 1 plus m1 into m2. We have this prepared formula. Fine. Now we just put values of m1, m2. We simplify. Okay. So what is m1? That is m minus 2m upon 1 plus, this is nothing but the 2m square equals to 1/3. Now because of the modulus we have here, this is just minus m. We have two possibilities. Minus m upon 1 plus 2m squared equals to 1/3. Or what is the other possibility? That is here again minus m upon 1 plus 2m squared equals to minus 1/3. Okay. Now this would be just, if you simplify, it would be quadratic equation. Minus 3m equals to 1 plus 2m squared. So 1 plus 2m squared, if I take on the other side, plus 3m equals to 0. This is simply quadratic equation, we know. Okay, so this will be 2m squared plus, here what we'll get? Plus we'll get the, here 3m plus 1 equals to 0. We need to factorize this. What are the factors here? 2m, m here. So 2m squared, I need plus 1. So I'll write here plus 1, here also plus 1. These are the factors. So either m equals to minus 1 by 2 or m equals to minus 1. Okay. So you can write here, one slopes are this. If it is minus 1, then slopes of the lines are here minus 1 by 2, sorry, then the 2m will be minus 1. And what is 2m here? 2m will be minus 2. So these are the slopes, minus 1 by 2 and minus 1. 1 is this. The other one is minus 1 and minus 2. This is m1, this is m2 if you just look at here. Same way you need to do here also parallelly. So there will be 4 possibilities actually. Minus minus will get cancelled here. So 3m equals to 1 plus 2m squared. So therefore you will get the 1 plus 2m squared minus 3m equals to 0. Fine. And now just the question is what? Factorization. So 2m squared minus 3m plus 1 equals to 0. So what are the factors here that we need to write? So we have here 2m. So here also m, 2m squared. I need plus 1 but minus 3. So minus 1 minus 1. So either m equals to half or m equals to 1 here. If m is half, then 2m will be 1. And if m is 1, 2m will be here. It will be 2. So these are the 2 more possibilities. One is half and 1 and 1 and 2. So these are the 4 possibilities for the slopes of the lines, right? What is important one here is you are given the tan alpha. One is this possibility, minus 1 by 2 and minus 1. It's double, minus 1 and minus 2. Then you have a half and 1, and then finally 1 and 2. So these are the 4 possibilities for the slopes of the given 2 lines. Question number 12. you are given that line passes through these 2 points. Okay. Which 2 points? One is x1, y1 and the other one is h comma k. So once you have 2 points, immediately you can get the slope. But slope you already given small m. So here slope which is already given small m, which is equals to y2 minus y1. That is nothing but you can write here y2 minus y1, that is k minus y1 upon x2 minus x1, that is nothing but h minus x1. Slope, this is given to you in the question itself. See the question. So I've just written this symbol and this obtained from the given 2 points. So from this k y1 equals to m into h minus x1. This is required equation. Just one line solution. Required expression. Required equation or expression. That's what you are asked. Okay. Question number 13. That is, as we did in which number? Have a look earlier. You did 3 points lie on a line. 3 points are collinear, which is question number 8. This is same as question number 8. 3 points are on the same line. So slopes must be equal and immediately you'll get that. Right. So h comma 0, I'll call that as a comma b, and c 0 comma k are collinear. They are on the same line means they are collinear. So what we do, for example, I'll use these two and get the slopes. I'll use these two and get the slopes. Any two can be used. You can use AB and BC, or you can use BC and AC also. That's not important. So I'll write the slope of AB is same as the slope of BC. Right? I already mentioned earlier that if points are on the same line, then by taking any 2 points, the slope remains same. You know, concept of the slope has something with the angle, not with the points. So if I select any 2 points from the line, slope will be same. Right. Like this. If I have any 2 points, these 2 points, or these 2 points, or these 2 points, slope remains same on the line. Selection of points on the line is not important to get the slope. So we have chosen AB and BC because they are collinear. Okay, what's the slope of AB? B minus 0 upon A minus H. What about slope of BC? K minus B upon 0 minus A. Okay. So we have this much. Now we'll just simplify. B upon A minus H equals to K minus B upon minus A here. Fine. Now the question is what? Simplification. So cross multiplication here, minus AB, A minus H into K minus B. We'll just open the bracket on the right hand side here. Minus AB equals to, here we have AK, then minus AB, then HK, and plus BH. This will get cancelled. Take HK on the other side. HK equals to AK plus BH. Now you look at it, required expression. You want 1 on the one side. So dividing by this. Dividing by HK. 1 here. If you divide by HK here, let me write one more step, no problem. Upon HK. Dividing by HK. If you do individual division, KK will get cancelled, you will get the A by H. Your HH will get cancelled, you will get the B by K. So therefore finally 1 equals to A by H plus B by K is proved. It's just concept is this much. Any two slopes I've compared, and this is just a simple algebra. This is not big task for you. The only important point is this. This is the only important point when points are collinear. In the next question, you are given this diagram. The first question is find the slope of the line AB. We want the slope of this. 2 points on the line you are given, so you can get the slope very easily. So slope of line AB, you know, y2 minus y1, 97 minus 92 upon x2 minus x1, 1995 minus 1985. So here it would be just 5 and this is 10, so slope is half. Okay. What is the next question there? You are asked for population in 2010. Now population comes from, just look at a diagram, you can very easily. Years are presented on the x-axis here. The year that is given to you, suppose this point C, 2010. Okay, what you want? You want the corresponding population, that is from here. So I want y coordinate of this point. Understood? That much only you need to understand in this entire solution now. What is asked? Find the population in 2010. Now 2010 is here. It will come from here, x-axis, you know. So the point C on the same line, where first coordinate is 2000. Now y coordinate you want to get. Y coordinate comes from where? Y-axis, population. So this is unknown, which we need to find. Okay, so we need to find y here. Let point C here as 2010 comma y. So what is this y? That is corresponding population. It is understood. Corresponding population. Corresponding population means what? Population in 2010. So we need to get this. Now what you have noticed from the diagram? We have used this concept 3 times. What you notice? These 3 points are collinear. Which 3 points? A, B, B, C and A, B and C. So here A, B and C are collinear. So by any 2 points slope remains same. So I'll write slope of AB, which you know you did it before few minutes, so which I can write here directly, equals to slope of, you can use these two or these two, whatever you want to use, choice is yours, and the slope of BC. Points are collinear, slope remains same by choosing any 2 points. Now slope of AB you did, which is half. How do we get the slope of BC? y2 minus y1, that is y minus 97 upon x2 minus x1, that is 2010 minus 1995. Fine. So this is how much? You know, this is 15. This is, we know 15. So I'll take on the other side. So here 15 by 2 equals to y minus 97. So therefore, what is y from this? That is 97 plus 15 by 2, which is just 7.5. So 7.5 plus 97, which is 104.5. That will be the population in the year, which year? 2010. So population, this is we know here population in 2010. Now here I suppose population data will be in crores, so this is 104.5. You can write crores here. Fine.